What causes the radioactivity in shale? Also, what causes heavy concentration of coal in places like Kentucky, southern Illinois, Pennsylvania, etc.? Is it based on vegetation that was there or something in the topography that aided the process?
Okay, you want to comment first, Joe?
Sure. So just I'll comment on the coal and the like. One of the most common questions we get is, why do you find coal here or dinosaurs here and not other places? And I like to make the point that in many of these deposits, they are certainly global deposits, but that doesn't necessarily mean that they are found exclusively globally without any breaks. And by that, what I mean is, if you just take the UK as an example, right? If you want to dig up dinosaurs in Norfolk, where I come from, you can certainly do that, but you'd have to dig down through 1,000 feet of chalk. Because we know the deposits are down there. We've boreholed all the way down, and the Jurassic deposits with the dinosaurs are there, but they're just buried underneath 1,000 feet of chalk. So nobody actually does that, right? Likewise, if you come over to where the museum is in Oswald Street, right, and it's mostly Triassic rocks around there, right, the sandstones. Well, we can trace where the chalk was, and we know that the chalk used to be there, but it's all been eroded away. Now, that erosion is very large scale, so we're most likely talking flood runoff, but the deposit was there at one point. So when you're dealing with the geographical location of things, shall we say, it does pay to take a step back and go, okay, well, where are the deposits? Were they here? Are they still here, but are they still buried? What's the larger scale picture? In terms of heavy concentration of coal in places like Kentucky and southern Illinois and Pennsylvania, well, again, as we've mentioned, you can trace these rock systems all around the world, the Pennsylvanian and the Mississippian, which is where you find the predominant amount of coal, or the Carboniferous as it's known in the UK. You can trace these all around the world, so it's a global deposit, and it's a global flood deposit, and has nothing to do with based on the vegetation that was growing where they currently are deposited, where they're currently buried. This is a mass scale burial, a very quick burial, and under the right conditions, you end up with coal. Now, you go to creationresearch.net, click on the coal experiments, and you'll find a number of interesting things about the rapid formation of coal. It's certainly a process, and it really does seem to be a process which is connected to clay, or the presence of clay. Now, if you get huge amounts of vegetation buried and it doesn't have clay present, that vegetation is either going to be destroyed or it's going to be fossilized in a different form. It won't form coal. So you've not just got the burial, or the quick burial, it needs to be under the right processes as well, which seems to be at the presence of clay, if you're actually ever going to get the coal in the kind of formations that we see around the world.
Okay, I'll tackle the other half, the radiation bit, because most coal is not even considered as young enough to be dated by carbon-14. However, you can look up the Radiocarbon Journal and find quite a lot of specimens of coal that have been listed in there in the early days. It's fallen out of fashion now, but you'll actually find many coal seams do give a carbon-14 date because they're actually made of carbon, right? So that sort of follows through. The unusual bit is the microscopic uranium that is characteristic of the Devonian shales through North America up into Canada. And there are some places, because Joe and I have filmed right up some of these valleys, there are very few places where these radiation sources actually seem to produce much harm, but they actually do mutate the plants, right? So we've actually filmed the mutated plants up where the edge of the shale comes through, and there's some suspicion that it does account for some human illnesses wherever they live too long on that. Nowhere near as many as if you take the basements in Philadelphia and that are made of metamorphic rock that's got radiation in it. And if you make your basement out of that, the radon gas, which is one of the byproducts of uranium decomposition, gets into your basement. Being heavy there, it stays there. So that is a serious source of radiation poisoning. But it doesn't seem to happen with the uranium, whether it's because it's just blown away or whatever, we don't know. Nobody builds their basements out of shale. It's just not strong enough. But as to its source, you would need to erode massive amounts of uranium, massive amounts of granite, massive amounts of metamorphic granitoid rocks, And that would be one way of producing microscopic uranium, which will either come in with the water, but more likely deposit it at the same time on a huge scale. So again, evidence of massive erosion somewhere else and mega deposition along with the fine silt that's here. Same as I talked to Craig yesterday, and the mega sandstones on the top of the mountains in Tasmania. There's one aspect which is usually never discussed, and that is for a cubic meter of sandstone, 1 cubic yard, a bit less than a cubic meter, 1 cubic meter of sandstone, you actually need 3 to 4 cubic meters of granite torn to pieces, and then the sand gets dumped in one place, the silty mud from the clay that comes from the arcos is dumped somewhere else. Yeah. So that's what you get, or you can get arcos as another byproduct, like in Central Australia with the Ayers Rock or Uluru.